Right, this first problem asks us to find the length of QV. I always think it's useful to put a variable in the diagram for the thing that you're looking for. So if we put an x over there, then we've got a 28-degree angle up in here. Okay, that should draw your attention. That's going to be very useful to us in helping us to find x. Okay. Notice we don't have this side of the triangle down here, because if we did, in addition to the hypotenuse over there, then we could use the Pythagorean theorem with those two sides to find x. But we're out of luck. We don't have this segment down here. But we do have that angle measure. Okay? So you want to give your attention to that corner of the triangle up there, and then ask yourself, okay, from this angle's point of view, remember what we talked about the last couple days, opposite sides and adjacent sides and hypotenuses. You want to ask yourself, the side that we're looking for, how does that relate to that angle? Well, in this case, this is the adjacent side. And here's a side that's going to help us find that one over there. That one is the hypotenuse. So we need one of those trig ideas from yesterday. And this word helps us remember the trig ideas and how they are defined. We need the one. Is it sine, cosine, or tangent? Which one connects adjacent and hypotenuse to each other? Well, if you can spell the word, you can see that the cosine connects adjacent and hypotenuse. Okay, so we want to write an equation with a cosine in it. Yesterday I was giving you cosine expressions, sine expressions, and you were telling me the value. Now you've got to write them. And what always follows a sine, cosine, or tangent is the angle measure. Cosine, in this case, of 28 degrees. And we know that cosine is always adjacent over hypotenuse. I like to start by writing down, in essence, the formula before getting in a hurry to plug things in. Okay, I'll show you what happens if you're in too much of a hurry to start plugging things in. So write down the formula for cosine of 28 degrees. And then plug things in. The adjacent is our variable. Cosine of 28 degrees equals x. And the hypotenuse is 75. Okay. So it looks like we're pretty close to solving for x, except what is all this stuff over here? Like, who knows what that is? Well, a long time ago, somebody learned what that was, wrote it down on a piece of paper, saved it forever, and you can look it up. In fact, your calculator also can tell you what this is. Right? Little detour here. You don't have to write this down in your notes, but a little detour. Suppose we have a right triangle with a 28-degree angle, and then we have a bigger right triangle, but also with a 28-degree angle. We know from last chapter, because these two triangles have two pairs of congruent angles, these triangles have to be similar to each other. And when triangles are similar, then we know the ratios of matching sides are always equal to each other. So if we have an adjacent and a hypotenuse there, that adjacent over hypotenuse has to be equal to this big adjacent over that big hypotenuse. And it's going to be equal to the adjacent over the hypotenuse for every other triangle that is a right triangle with a 28-degree angle in it. And so somebody figured out what that ratio actually is, and like I said, put it in a table of values that we can look up. Right? Or I'll show you how to get it out of your calculator in a moment. But here's a table, and here's the cosine column. Here's a sine column, a tangent column. Cosine, we want to go down to 28 degrees. There it is. There is the value of cosine of 28 degrees right there, 0.8829. Might be a little bit difficult to see on that video, but that's the 4-digit decimal value. 0.8829 equals x over 75. Now, that was supposed to be a ratio of two sides. It doesn't look like a ratio, but if you just put it over 1, now that doesn't change the value, and now it looks like a ratio. Okay? Now, the truth is, we didn't need to do that to solve this equation, because all that's required to solve this equation is to multiply both sides by 75, to cancel out the division by 75, pick up your calculator, and do 75 times 0.8829. That comes out to be about 66.2. 1 decimal place is fine for me. There's the value of x. Okay. And in most all of these problems, it's not difficult at all to decide whether or not your answer seems reasonable. Put it back in the diagram, 66.2. Is that reasonable? Well, maybe you think so, maybe you're not sure. I'd tell you what would not have been reasonable. 86.2 would not have been reasonable, because we know in this triangle the hypotenuse is 75, and the hypotenuse has to be the largest side. Any answer that we would have got bigger than 75, we would have had to reject and then go back and try to figure out what we did wrong. Okay? And then finally, I warned you a little bit earlier about not being in a rush to plug things in or write numbers down right away, but just start with the general formula. Because if you're in a hurry to start writing numbers down, here's what I see students do occasionally. They'll start by realizing they need a cosine here, and they'll write cosine of 28 degrees, and then they'll be in a hurry to look that up in the table, and they'll find out that it's 0.8829, and they'll write equals 0.8829, and then they'll look at that equation, and then they'll say, Mr. Nortillo, what do I do now? Okay, there's no variable in this equation anywhere. There's nothing to solve for. There's nothing to do. Okay, because they were in too much of a hurry to write numbers down instead of starting with the general formula and then plugging things in. Let's go on to number 2. Okay, find the length of PB. Let's put a variable there. That 25-degree angle needs to attract your attention. It needs to. Okay, and so from this corner's point of view, the variable we're looking for is the adjacent side. This 36 is the opposite side. You think back to SOHCAHTOA, and you're looking for something that connects adjacent to opposite. Well, there it is right there. Adjacent and opposite are connected by tangent. So you have to write a tangent equation. And you always put the angle measure inside the trig. Whether it's a cosine, a tangent, or a sine, this is always an angle measure. Always, always, always. And that's equal to, don't write any numbers down, write down the formula. Opposite over adjacent. Okay? Now we can look up tangent of 25 degrees in the table, or okay, you can find it on your calculator. If you've got one of these calculators, turn it on. Okay? And then, before you do anything else, press the mode button on your calculator. And that will take you to a screen that looks like this. And the third row down here says radian degree. You want this calculator set to degrees. So if you need to, arrow down and then arrow over to degrees. And then you must hit the enter key so that the setting changes from radian to degrees. So hit the enter key, and now you can see degree has been selected. Now we can quit out of this screen. Second, and press the mode button. You can see right above the mode button it says the word quit, and that will take you out to the main screen. Now we can get the calculator to tell us what the tangent of 25 degrees is. Instead of looking it up on the table, press your tangent button, which is right here. There's your tangent button. Okay, and that comes right up on the screen. You can see tangent, put in 25, close the parenthesis, hit the enter key, and there's your decimal. I would write down 4 decimal places. At least 4, but 4 is good enough. Because if you don't write down 4 decimal places, your final answer is likely to be way off. So the tangent of 25 degrees is this. The opposite is the 36. The adjacent is the x. Look what happened this time. The x ended up in the denominator. That's going to happen to you half the time. There's no way of predicting ahead of time whether the x is going to be in the numerator or in the denominator. Denominator always makes the algebra more difficult, but you just got to deal with it. Okay? And in a situation like this, it is really useful to make that decimal look like a ratio. Okay? Because now we're ready to cross multiply. 1 times 36 is 36, and what is 0.4663 times x? Well, it's just 0.4663x. Now to solve for that x, we want to divide both sides by that nasty decimal number so it cancels out. Okay, so it cancels out over here. We put 36 over 0.4663 in the calculator, and we get x is approximately equal to 77.2. Does that seem reasonable? Well, this side looks like it should be longer than that one. I don't know. Neither one of these is the hypotenuse, so I'm not sure which one should be the largest. Okay, but that looks like a reasonable 25-degree angle to me. So I think it's reasonable to expect that this segment should truly be longer than that one. 77.2 seems reasonable. Moving on to number 3. It's just more of the same. Looking for segment TR, put an X there. This angle needs to draw your attention. From this angle's point of view, this side is the opposite. This side is the hypotenuse. So what connects opposite and hypotenuse? From that word SOHCAHTOA, there they are, right there. We need a sine equation. So sine of 49 degrees equals opposite over hypotenuse. Sine of 49, I'm going to punch in my calculator. Calculator tells me that is approximately 0.7547. The opposite is the x. The hypotenuse is the 54. Oh, I love it when the variable's in the numerator. That makes life a little bit easier. Multiply both sides by 54. Punch that in your calculator, and you will get that x is approximately 40.8. One more example. We're looking for KC. Put the x there. From this angle's point of view, we're looking for the hypotenuse. The one side we know is the adjacent. What connects adjacent and hypotenuse? It's the cosine. So cosine of 26 degrees equals adjacent over hypotenuse. Looking up cosine of 26 in the table or punching it in my calculator, I get 8.8988 equals, the adjacent is 87, the hypotenuse is the variable. Dang, x ends up in the denominator again. Well, you can't get away from that sometimes. Cross multiply and we get 0.8988x is equal to 87. Divide both sides by 0.8988 and your x comes out to approximately 96.8. If you're just filling in these notes for the first time and not reviewing this lesson, what I want to ask you to do is pause the video right now and try to do number 5 on your own. Go ahead, pause the video. All right, if you paused and just came back, here's the solution. We're looking for WH, which is the adjacent side. This is the hypotenuse. We need cosine to connect those together. Cosine of 22 degrees is equal to x over 75. After you get the decimal value for cosine of 22 and you multiply that by 75, you will find that the x value comes out to be approximately 69.5. Try number 6 on your own. Pause this video and then try number 6 and then start the video again. Go ahead, pause. Alright, if you paused, you start it up again, here's the solution. We're looking for AE. From that 61 degree angle point of view, that's the hypotenuse. This side is the opposite. We need sine to connect those. Sine 61 degrees is the opposite over the hypotenuse. Sine of 61, according to my table, is 0.8746. And that's equal to the opposite, which is 44, over the hypotenuse, which is x. Going to have to cross multiply. When you do the cross multiplying and the dividing, x turns out to be, let me punch this in real quick. Whoops, I started doing it wrong. 44, and we get about 50.3. Okay. Good luck on the homework.